Our last speaker for Futurescape. All right, we will have Prof. Hussain Kayiem from University of Technology Petronas on green technology, speaking on solar, the future of green energy. This presentation will explore the utilization technologies of solar energy and the current researchers' trends to solve the main setback of non-availability of solar in the night.
Assalamu alaikum and good afternoon. I propose to start in the morning, but my colleagues take longer time, so they override me. Anyhow, I am Professor Hussain Kayiem from University of Technology Petronas, and I am chairing the Green Technology Working Group in Myron since 2011. And I am going to present to you some of our effort on the utilization of solar energy and to prove the concept that there is solar potential for energy in Malaysia. I will cover those introductory remarks on what is the sun and the solar energy and the solar technologies mainly for power generation and our effort in UTP as Solar Research Group on the solar technologies to prove that there is potential for solar energy in Malaysia. I start with this statement by Thomas Edison. Thomas Edison said that we are, as a farmer, looking for fuel near our fence of our farms. But in fact, there is no need because it is available. All the renewable energies are available. And he said that the best that I can invest is the sun, meaning the solar energy. And he is correct. Why I support his statement and I say it is correct? Let me show you this. What we needed during a year, it's around 16 terawatt per year. And this 16 terawatt per year, if I compare it with the solar and the other resources of energy, it is something like this. So this is the 16, and this is the available energy from solar during the year. And those are the other possible resources of energy in the world. If you look, definitely you can make the decision that solar is the future for the energy production. However, what is the scenario when we are receiving the solar radiation? How it's come to the earth? I call it the scenario of solar radiation. If this is the sun, then out the atmosphere we are receiving 1366 watt per meter square radiation. When it reaches the atmosphere, some of it reflected back, some of it is diffused, and what we receive, what we call it the direct radiation to the earth. Now, it is something like this. This is the incoming radiation, some of it reflected back due to the dust and the cloud, and what we receive is this portion directly. In this slide, I am going to touch a little bit about the greenhouse and what is the trapping of the thermal energy in the earth. Right. Here, if you look, there is activity, thermal activity on the earth from thermal power plants, from evaporation and reflection of solar radiation. And this is usually escape to the environment through the atmosphere to the outer space. Unfortunately, with the presence of the greenhouse or the emission of the CO2, we will have a barrier. This barrier prevents the radiation to escape and its return back and the trap between the cloud of the gases, the emission gases, and the earth. And this is alerting issue. We have to look into this seriously in the near future or in the very, very near future. There are many signs of global warming and affecting the climate seriously. However, this is not the subject of my presentation. My presentation subject is how this portion of solar energy can be utilized. We received this one, how we utilize it. And there are many technologies to utilize the solar energy. We are focusing on the power generation by solar energy. There are another technologies or another utilization of the solar, but let us look into these techniques. How solar can be converted to a power. There are three techniques to convert the solar to power. The first one is the PV, and all of you are aware what is the PV. And the PV is conversion of light into electricity using semiconducting material that are possessing photovoltaic effect. And the most application of this phenomena is in the solar PV. So the PV panel converts the solar radiation into electricity through chemical reactions in the material of the PV. Right. I present some of our effort on the PV utilization, and we have established a UTP 10 kilowatt system to generate electricity. What is the uniqueness of this 10 kilowatt system? It is different than what is available or what has been established by PV panels to generate electricity. First, we have a good bank of battery which secure 24/7 generation of electricity in case there is no sun, there is a cloud, then the battery storage is enough to maintain the supply of the power. Second, it is connected to the internet through Myron network, and any user in the world can get a password from us. He can enter to the system and he can monitor all the parameters in the site. So we utilize Myron and through UTP server, and we upload the information through this system. And the other issue that we are generating 24 volt and we generate 48 volt to integrate with another systems. Then I can conclude that the uniqueness of our 10 kilowatt PV system, it is a 24/7 power supply, two outputs or two different outputs, and it is remote monitoring through the internet using Myron network, and it is globally accessible for real-time data sharing. Anyone in the world just get the password from us. He can monitor the temperature, he can monitor the solar radiation, the power production, and so many parameters in the site, in our solar site. This is about the PV. The next technology, where we used this 10 kilowatt PV, we are operating our zero energy postgraduate office. This is a postgraduate office in the site, and we utilize the 10 kilowatt generated by the system to operate the system, and we are using environmental friendly air conditioning system called solar assisted air conditioner. We come to the thermal. The solar thermal can be split into three different categories. Point concentrating line concentrating and non-concentrating, or updraft system. I go a little bit through each one and what has we done for each technique in our system. Right. First, I start with the solar updraft power plants, which is now represent a revolution in the world, and many countries like US, Spain, Australia, they are moving toward this technology. They are investing in this technology. The updraft power plants can be split into two types: solar chimney power plant and solar vortex power plants. What is each one is representing, how it's work. The principle of solar updraft that we have the solar radiation penetrated through a canopy, transparent canopy, hit the ground, and you will have stream of air. The stream of air goes through a tower, and there are wind rotors to generate electricity. It is something like this, the continuation of the process, that you have air stream and you have a turbine to generate electricity, can be standalone or can be network connected. It is very simple, robust, sustainable, and long-lasting technology with low-tech, no need for high-tech. And this movie can show us the principle of the operation of the solar chimney power plant. Yeah. The ground is heated, and you will have heat transfer from the ground to the adjacent particle of air. Stream of air is created inside the collector, and you will have airflow. The airflow operates wind rotor, and the wind rotor connected generator to generate electricity. And it can be enhanced by thermal energy storage to support the operation during the night. So far, there are two prototypes have been implemented in the world, one in Spain and the second in China. This one in Spain, built by the German Ministry of Science, and this one is in China, and the properties or the characteristics of each one are represented here. Many other projects are under construction. This is some of them. And if you look here to the height of the chimney, the height of the chimney, now they are talking about 1 kilometer height to get feasible production of electricity. And there is one in Australia, another one in Spain, the second one, and in Namibia and USA there are 3 or 4 projects in Virginia and California. However, most of the investment or the cost go to the chimney construction. And this is what we are thinking about, replacement of the solar chimney or the tower by another technology, and I will come to this. Now, what is about the night and the cloudy days? In the night and the cloud days, there is no solar. What can we do? We have tested two techniques in our solar site, and we proved that both of them are applicable. We use thermal energy storage, very simple, and we use integration with external heat source. As you see here, we used matte black painted bubble. We found that this bubble absorbed the solar energy, solar radiation, and store the thermal energy, and after the sunset, release back the thermal energy, and there is continuation of the production of electricity. So we proved that it is workable, and I can show you that the system can operate by this movie. Unfortunately, it is turned by 90 degree. So you see that the turbine is rotating. Where is it? I can't see. Yes. So we generate electricity, small amount of electricity, and the idea is to prove the concept. The concept applicable in Malaysia. Okay. Back again. We tested another technology to integrate the external thermal source with the solar. So the idea here that we inject hot gases underneath the collector in the day, during the day, in the presence of solar energy, the absorber absorbs the radiation and generate the wind stream to operate the turbine. In the night, the flue gas transfer heat to the absorber and again generate air stream to operate the system. So here, successfully, we proved this by this experimental work. We utilized a gas turbine, domestic gas turbine, and we utilized the flue gas from the turbine, and we operate our system in the lab. Then we went out to the site, and we tested the system, and we found this operate beautifully. So by this, we generated electricity 24 hours 7. The other technique that we are utilizing, the solar chimney power plant, which we have it in our site, and we designed a flue channel. We inject the flue gas through the channels, and those channels exchange heat with the air. And in addition, the exhaust, we injected again in the tower to reduce the pressure and increase the temperature, then we will have higher stack effect. So the system has been proven is very successful, can generate power 24 hours 7. And we proved this by experimental work and numerical work. I come to the second technique of the updraft. We name it solar vortex engine. What is the solar vortex engine? This is a natural tornado. This is what's happened in the environment or in the atmosphere. The tornado, when it is created, it can go up to 10 to 12 kilometers in the atmosphere. So we thought, why we are not utilizing this phenomena and bring it to the solar chimney. Instead of the tower, let us use this natural phenomena. And the technique started by the guy, Louis Michaud. He is an engineer, and he got a good research fund. And he suggested that he is using heat exchanger here with plant to generate steam and exchange the air, the heat with the air, and create a vortex, artificial vortex. This artificial vortex go up in the environment to replace the tower. What we did, this is the experiment by Michaud. What we did, in fact, we proposed, why don't we mix between the solar chimney and this solar vortex engine, sorry, the atmospheric vortex engine. So we invented a new technique that this is a vortex generator engine, and this is the solar collector. And we established this solar collector in our site so that the air is heated up under the collector and go up into this very simple engine and generate the vortex. Okay. And we implemented this experimental prototype, and we tested this prototype in our site, and we successfully generated electricity. This is the shape of the engine, and the air enters in this annulus from underneath the collector and generate the vortex. I can show you a video here. Again, Diva, I think I need you. Diva. Yes. Successfully, we have this wind turbine, has been designed by Mr. Ali there, and he connected the turbine to the generator, and as you see here, it is running in a high speed, which means that the technique has been approved. Okay. What's next? We come to the other type of thermal technologies for the solar power generation, which is called trough concentrators and heliostat and tower concentrators. So, using those two techniques in UTP, we are intended to generate power and to utilize the steam generated for enhanced oil recovery. And we have established a plant of concentrator. We have Mr. Sinan who is sitting there. He is working on this trough concentrator, and he is under the process to complete his equipment. And we have another set of heliostat and tower, and successfully we generated superheated steam in this evacuated tube. This superheated steam can be connected to a steam turbine or can be utilized in the field of the oil for enhanced oil recovery. We have seen that it is not practical to have the power generation system at the top of the tower, so we have come in with the idea of we implement all the system of the power generation here, and we use a reflector. So we'll have from the solar reflected by the heliostat to another mirror or reflector on the top, reflecting the solar radiation, then everything is on the ground. And this reduces the complexity of the maintenance and the installation cost. With that, I come to the conclusion from our effort on the solar technologies that solar is the largest source of energy to the earth. So it is the time to think seriously to utilize this big source of energy. And second, the overdraft solar technology is clean, cheap, repost, and it is very promising solution to generate clean power or green power. And about Malaysia, solar steaming by solar concentration technology has potential in Malaysia, and we have proven this in our site, and this can be utilized for power generation or for enhanced oil recovery technologies. With this, I close my presentation and thank you for your attention.
Thank you, Prof. Hussain. Do you have any questions? Right. No questions. Thank you, Prof.